Hello and welcome back. This is week 2 of quarantine teaching, or as most people are calling it, e-learning. We are going to continue on from the notes that we started last week. Hopefully you all can hear me better. I am trying an alternate microphone from the computer that I used last time, so hopefully you can hear me better now. So, let's get going. For the meme for the day, I'm going to try to continue the memes for the day. Hopefully, I'll remember soon and I will upload the notes, PowerPoints up to Classroom so you can see all the glorious memes that I'm sure all of you are missing. Anyways, let's get to work. So last time we were talking about solutions, the different types that we had, the mixtures that could be confused as solutions, such as suspensions and colloids. Quick note on that, do not forget that suspensions and colloids are not solutions. They are a mixture that can sometimes be misconsidered or misidentified as solutions. They are not solutions themselves, but they can look like one sometimes. So we want to make sure that we don't make that mistake. So suspensions and colloids are not solutions. So let's talk about the types of solutions that we have. So the first type that we're going to talk about is an unsaturated solution. An unsaturated solution is any solution that contains less than the maximum possible amount of solute dissolved at any given temperature and pressure. What that means is if you pour lemonade into water and you make lemonade, that's normal and that's a normal unsaturated solution. 90% of solutions that are made in the world are unsaturated. They do not contain the maximum amount of solute. It's not something that unsaturated is the normal type of solution that you find. Anything that we worked with in class, anything that most of the things that you work with in your kitchens, anywhere you deal with solutions, it's going to be an unsaturated solution 90% of the time. Um, Generally, if it's not a saturated or oversaturated, which we're going to talk about in a second, it's going to be unsaturated. That's the easiest way to identify it. It's the majority of it. So if we have an unsaturated, we're obviously going to have a saturated. So what does that look like? A saturated solution is a solution that contains the maximum possible amount of dissolved solute at a given temperature and pressure. Okay, not hard to, it's just kind of the opposite of unsaturated. So how do we know? How do we know when a solution is considered saturated? Well, we know because if we add more of the solute, it's not going to dissolve. It's just going to settle at the bottom of the glass, the bowl, whatever you're dissolving it in. So if any of you have ever made bird feeders or a hummingbird feeders especially, if you make a hummingbird feeder, you're basically just adding sugar until the sugar um, kind of just stops dissolving. You just add it until you get a little bit of sugar resting at the bottom of the feeder that doesn't dissolve. That's how you know that you have a saturated solution. If you're going to do that with salt, you do the same thing. You just add salt, stir it up, add salt, stir it up, until eventually you just end up with salt crystals at the bottom that don't dissolve into the water or whatever you're trying to dissolve it in. That is what's considered a saturated solution. And when you're not dealing with the unsaturated solution, you're probably dealing with a saturated solution. Saturated is very easy to tell. There's usually just a few crystals at the bottom of whatever you're dissolving in. If you make, there's a few different things that can be considered saturated. Most of the time, none of your drinks will be considered saturated. Most of your kitchen stuff you wouldn't want saturated solutions just because there's so much in it. It's one of those saturated solution would be if you made a saturated solution of Kool-Aid, it would actually be a very, very, very sweet. It'd almost be too sweet. It'd be like drinking the powder straight, and that's even for me, that's a little bit much. And y'all know how much I love Kool-Aid. So that's a saturated solution. So there's unsaturated, which is there's not the maximum amount of solute. Saturated, in which there is the maximum amount of solute. That's all it can take at a given temperature and pressure. And then there is supersaturated solutions. So supersaturated solutions are a little bit different, and they're very, very easy to identify. What they are is they are solutions that contain more than the maximum possible amount of dissolved solute at a given temperature and pressure. Now, let's think about that. It contains more stuff than than it's supposed to be able to take in a normal situation. So how are we going to put more sugar or more salt or more whatever we're dissolving into this solution than is actually physically possible in a given situation? Well, same way you do anything in the extremes. You change the situation. For what that means for solutions is we have the maximum amount possible at a given temperature and pressure. So what we do is we change the temperature and pressure. The easiest thing to do is to start to heat it up, change the temperature, and increase the temperature to allow for more of the solute to dissolve. This is very common if you were to make something like rock candy, or rock candy is the easiest thing to think about at the moment. If you ever actually want to make rock candy, we might actually have a lab over it next week. The easiest thing to do for it is you just take a lot of sugar, you just dump it into water until you make what's a saturated solution, then you turn up the heat, and then you wait, you add more sugar, and then you just you get it till it's hot, put more sugar, and you just keep doing that until you get to a point when you've got this thick syrupy type substance, and then you leave that out to cool, and what will happen is that it will crystallize into these sugar crystals, into the large sugar crystals that people know as rock candy. So that's what supersaturated solution is. If we were What this is used for in an actual chemistry lab or any kind of lab really, most kind of labs have what's known as baking powder or baking soda. We usually keep sodium bicarbonate, a supersaturated solution of that, near the acids and bases cabinet. We do that because that cabinet, if something spills, it is a base to neutralizing agent that we can just throw on. It's super saturated, so it's super easy to make. You just throw in stuff in, you throw stuff in until finally he's like, oh, yeah, I see. There's stuff at the bottom. We're good. We made enough. We're done adding to it. You make it so that you have it on hand just in case. Most labs in the world have a jar of it. It's really good, really helpful to use. So that's three different types or classifications that a solution can be. Now, we're almost done with the lesson for today. We just have one more thing we're going to learn and then some practice. Because what we're going to learn is the math, or the starting math, probably the most important math section of the chemistry world. If you take any kind of chemistry, physics, even higher level biology, even lower level biology, honestly, you're going to be using this equation for all of that. If you continue with science, you will run into this equation again. I guarantee it. This is an equation that I use on an almost weekly basis in our class and have been using to make the solutions that you have been using in your labs. What that equation is it is the molarity equation. So the molarity equation is an expression of the concentration of a solution in moles of dissolved solute per liters of solution. Now, I know this is a lot of very big brain stuff right now. Take a moment, read it again. Molarity is an expression of concentration. Concentration is how much stuff is in a solution. We express the concentration in chemistry in terms of moles. We want to express it in terms of moles because remember, that's what's important to us. If we did it in grams, it wouldn't be nearly as effective. We'd have to consider what it is, etc., etc. But with moles, oh, there's 3 moles of that. Doesn't matter how much it weighs. There's 3 moles of that solute in how many liters of solution. Now, this can lead to problems, and we'll talk about those problems later on, and the pros and cons of using this system. But for right now, this is what you need to know. So, the easiest way to learn about molarity is learning that molarity is moles of solute over liters of solution, which also gives molarity the mixed unit of moles over liters. So let's take some practice with this. I know some of this is a little bit scary. I'm not going to be there to help you as much, but I promise you this is not that bad. You will, once you get it, you'll be wondering why you're ever worried. So let's take a look. If you have 3 moles of solute dissolved in 1 liter of solution, what's the molarity? Well, looking at molarity, we have moles over liters. So we have moles, 3 moles over 1 liter. 3 divided by 1 is 3. Not too bad, right? Okay, well, what about the next one? We have 1 mole of solute dissolved in 0.5 liters of solution. So, moles over liters, 1 mole divided by 0.5 liters. 1 divided by 0.5, what's molarity? 2. 2 molar. 1 divided by 0.5. Still not too bad. Let's see what the third one is. If you have 0.2 moles of solute dissolved in 1 liter of solution, what is molarity? Moles over liters. So 0.2 over 1. Anything over 1 is what? Anything. So 0.2 over 1 is 0.2. Very good. See? I promised, told you, it's not too bad. Now, these are a little simplified, but simplified just means we used whole numbers instead of what we're going to be using otherwise. So, not too bad. Let's get into it. So, to help us in our endeavors, I have brought up the handy dandy drawing. So we're going to try and do this. So, our first thing, we have what is the molarity of a 0.3 liter solution containing 0.5 moles of NaCl. Now I want you to notice that this is not any different than the ones we just did right here. Nothing is different. We just put a little bit more stuff in there. So let's get to work. What do we know? We know we have liters is equal to 0.3 liters. That's not big enough. And we know that we have moles of 0.5 NaCl. Well, molarity is equal to moles over liters. So moles will go right here. 0.5 moles over 0.3 liters. Now, important point I want to make here, it has to be liters of solution. It cannot just be liters of solvent. It has to be liters of solution. That's an important distinction I want to make now so that we're not forgetting later, because liters of solution and liters of solvent are 2 different things. So, all you gotta do is put moles over liters, which we did. So 0.5 divided by 0.3 is equal to 1.667 mole. So we have a 1.667 molar solution, which turns into 2 molar